There are three main strategies that I find beneficial to teach students when they are learning division. They are the sharing strategy, the Big 7 strategy, and long division. Along with the algorithms that students develop themselves to solve division questions, these are the three that I find are the easiest path to use to teach division efficiently to students as they begin to work with larger and larger numbers. Developmentally, students begin by sharing with concrete materials, but eventually students need to translate that on paper. The sharing strategy is a way for students to be able to show what they've previously done with concrete materials and move it into more of a pencil and paper demonstration of their understanding of division. It does require them to have a basic understanding of how to decompose numbers and multiples of friendly numbers like tens, fives, ones, and twos. The Big 7 strategy is often the second strategy, and it's a nice transition to move to a more procedural way to show division. It uses the friendly numbers of 2s, 5s, 10s, as well as 20s, 50s, and 100s that are well known for students, and they use them as a bridge to help students break down the numbers that they're dividing. It's more efficient as the numbers that students are working with become larger, and there's less room for error than there is with the standard algorithm when using those larger numbers. This strategy is helpful to transition students towards using a standard algorithm because students see more of the whole numbers being used as opposed to This strategy is helpful to transition towards the standard algorithm of long division because students actually see the whole number being used with their proper place value positions, unlike what occurs here in the standard algorithm of long division. Finally, the standard algorithm of long division is standard for a reason. It is the most efficient way for students to divide, especially when the numbers are getting larger. However, unlike the Big 7 strategy, students may miss the conceptual understanding of what is occurring when dividing and can easily get caught up in simply just memorizing the steps of divide, multiply, subtract, and bring down. The numbers in a long division question do not accurately represent the proper place value of the numbers, such as this 6 and the tens column really represents 60, but many students will miss that conceptual understanding, whereas in the Big 7 strategy, if they learn that first, they'll be able to see the commonalities between these two and transfer their understanding conceptually from this Big 7 strategy over into the long division, where they can efficiently get to the answer a lot quicker. Long division success in students does require students to have quite the strong foundation in their multiplication facts and knowledge so that they can get to this answer without having to use friendly numbers, such as in both the Big 7 strategy and the sharing strategy. So now I'm going to demonstrate how to use each strategy to solve the problem 87 divided by 3. Using the sharing strategy, students know that they need to break apart 87 into 3 equal groups. To start with this strategy, I would always start with manipulatives and then transfer this into more of a pencil and paper task so students understand how they would write this down on their paper. Students start by looking at this number and knowing that they need 3 different groups, so they draw 3 different circles. And now they need to share 87 into these 3 equal groups. Now, if you're dealing with smaller numbers, students can share one at a time. Say if this was 17 versus 87. That's not really the most efficient strategy when you're working with 87. So students need to learn how to break apart 87 by looking at the 2s, 5s, and 10s and grouping how they share. So students will start by saying, if I put 3 10s, that's 30. and I take 30 away from 87, and now I have 57. Well, I can add another 30 to that. So I put 10 more in each group. And now I've taken 30 away again. Well, now I have 27. Now, for some students that might have strong multiplication knowledge, they would know that if they added 9 more in each group, they would get 27. However, most students using this strategy will heavily rely on their friendly number knowledge of 2s, 5s, and 10s. So most students will then start sharing 5 in each group, which is 15, and do the subtraction. And again, students might see if they know that 3 times 4 is 12, then they would just add 4 to each group. But again, going back to that friendly number, I will then start sharing 2 in each group, which is 6. And if I share 2 more in each group, and finally I hit 0 remainder. So this strategy does take students a little bit longer and is not so efficient when students are working at 3 and 4 digit by 1 or 2 digit division questions. It becomes much more cumbersome at that point, which they should be transitioning to a more efficient strategy once their numbers that they're dividing start getting bigger. But this is the starting point. The next strategy of the Big 7 strategy, you put the 87 and then you simply draw a big 7 around the 87, which is why that's called the Big 7 strategy. And then you make a friendly number chart, looking at your 2s, 5s, and 10s, and then again 20s, 50s, and 100s. Now, the benefit of the Big 7 strategy is that students do not have to rely necessarily on a strength in multiplication because they can write out these answers here. So if you have students that are lagging in their multiplication facts, this is a strategy that they can use that helps to scaffold their understanding until their multiplication skills pick up. And they just answer the questions in their friendly number chart. So we have 6, 15, 30, 60, 150, and 300. And if students understand multiplying by 20 and 2 and the relationship there, then this becomes easier. So there is some background knowledge that students are required for the Big 7. So the first question students ask is how many times, what's my biggest number that is less than 87? Well, that's this one right here. So already you can see compared to the sharing strategy, we're cutting out one step because we're going by 20 as opposed to 2 groups of 10. So 3 times 20 is 60. And then we do some subtraction to see what's left over. And we've got 27. And now we look, well, it can't be another 10. So we've got to use the 5. So 3 times 5 is 15. Again, if students know that 3 times 9 is 27, they can just skip some of these steps and go straight to there. If not, they can still go back to their friendly number chart and keep plugging away at it. 3 times 2 is 6. And then 3 times 2 is 6. And subtract. And finally, we end to the 0. So students can rely heavily on this friendly number chart, or they can rely on their knowledge of multiplication to help them to be a bit more efficient with this big number strategy, but it does allow for students to have a little bit of a scaffolded crutch when dealing with division if their multiplication skills are not as strong. Finally, with long division, this is the standard that most people know, and it's standard. Again, like I said, for a reason, because it is the most efficient. Unlike with the other two strategies, students are not relying on friendly numbers and a lack of multiplication skills. So long division becomes that much more important, that students have a strength in multiplication so that they can work through the steps of long division, which is division, multiplication, subtraction, and bringing it down. So we put 87, and 3 goes into 8 2 times. Multiplication, 2 times 3 is 6. Subtraction, 8 take away 6 is 2, and bring down the 7. 3 goes into 27, 9 times. Multiplication, 9 times 3 is 27. 27, take away 27 is 0, remainder. So those are the 3 different strategies that I work my students through for division. They do come up with their own student-generated algorithms, especially you may have students with long division who figure out that they don't need to do all the stuff down here and they can actually do short division, and you'll have students taking shortcuts here or representing this in a different way. They might just write it out as a list or break this number apart differently, such as breaking it into 80 and 7 and then dividing both separately. They could do that as well. And they may share things differently as well. Using student-generated algorithms as well as teaching these 3 key strategies are important for the instruction of division and teaching students how to move from their primary sharing strategies into the most efficient long division strategy and being able to develop and maintain that conceptual knowledge throughout.